Alright, 3.1, practice 97 through 98 evens, and I spent a lot of time on this, probably more than I should have. It took probably over an hour, but look at this. Look what I got in the little corner for you. I got a little something something to remind you to show your work. That's just gonna sit there on every video from now on, and I'm just gonna have to make it bigger if you can't see it there, but yeah, it was originally just going to be at the end of the video, but then I was like, no, it can be there all the time. So you have no excuse. Look at it. Look at all the work I put into that. And I even turned a little seatbelt into a pencil. Isn't that cool? I'm proud of it. And now you get to see it forever and ever and ever. Show your work. It's the law. Okay. 31 point whatever I said. Okay, you get it. You can read. You don't need me to tell you. All right. For questions 1 through 6, we are graphing. It says plot the following ordered pairs on the same Cartesian plane. All right, start with 2, 3. We find 2 on the x-axis. Remember, we crawl before we walk, and then we go up 3. 1, 2, 3. Remember, we don't count from here. We don't count 1, 2, 3. We count 1, 2, 3. Just an important little note there. So that's our first one. Oops, I just did an odd for you. That's a freebie. All right, we meant to do number 2. Number 2, 4, negative 1. Find the 4, go down, negative 1, right here. Number 4, 6, 0. We start on this axis, find the 6, and then 0, we don't take any steps, so we'll stay right where we are. And then for number 6, we got 0, 0, 0, 0 is, of course, the origin, the middle. We don't do any moving. We go exactly right there. For questions 7 through 12, it says find at least 3 ordered pairs by using a table. So let's go ahead and write the equations we're going to be using. And remember to find if they don't give us any ordered pairs already, we just need to create that table and plug in one value for x and see what the y is, and that will give us the ordered pair. All right, so usually the easiest ones to start with are 0, and so we'll see what that one looks like. If x equals 0, we got negative 0, which is just 0. 0 plus 4 is 4, so 0, 4. If x equals 1, negative x, replace that x with 1, we have negative 1. Negative 1 plus 4 gives us 3. And then we got, if we do negative 1, well, let's do 2 for this one. 2, negative 2 plus 2 gives us 2, so we got 2 gives us 2. That was a little confusing. 2, 2, and you can keep going, but they only ask for 3. So the 3 ordered pairs would be 0, 4, 1, 3, 2, 2. But usually the 3 I like to start with are negative 1, 0, and 1. 0 is always important. 1 is just easy because you don't have to multiply really because it's itself. And then negative 1 just so we can see what happens if we have negative numbers. So those are the normal 3 I like to use, and that's the 3 I would like y'all to use for most of these examples. Obviously, sometimes negative 1, 0, and 1 won't give you the best results, but that's what I'll go ahead and teach you. Okay, so for this one, let's do our substitution. Replace that x with a negative 1. We have negative 1 times negative. That gives us positive 1. 1 plus 3 is 4. If we plug in a 0, 0 is easy. That goes away because it's 0, and then we just have 3. And then if we have 1, we have negative x. That becomes negative 1 plus 1 gives us 2. Once again, our ordered pairs would be negative 1, 4, 0, 3, 1, 2. What does it mean? What's the interpretation of these ordered pairs again? It just means that those x and y values, if we substitute them, if we substitute a negative 1 here and a 4 here, then these two sides are going to be equal. It's going to be a true statement because these two things will have the same value. That's all it means. And remember, if we put it on a graph, they would create a straight line as well. So let's keep going. Let's substitute our negative 1. Negative 1 times 2 is negative 2. Minus 12 gives us negative 14. 0, replace our 0 right here. 0 times 2 is 0. 0 minus 12 is negative 12. And then lastly, 1, 2 times 1 is 2, minus 12 gives us negative 10. So those are 3 sets of ordered pairs for each of our little equations there. Next, 13 through 20, they want you to graph after plotting at least 3 points. So we'll do the even. Actually, I'll only do a couple of them for you. I'll do 14. No, I'll do the ones with fractions for you just to help you out. So I will do 18 and 20. All right, so the question says we want to graph after plotting. So in order to graph, we need points, and to order to get points, we need to make a table again. So let's start with our the ones I taught you before, -1, 0, and 1. But it's not going to be as nice this time, and I'll show you how we get around that. So let's start with 0. 0 times 1/3 gives us 0, minus 3 gives us -3, so there's a point. Let's do 1. 1 times 1/3 is 1/3, minus 3. So if we wanted to do that fraction there, that'd be kind of complicated. And maybe you might say, oh, we can clear fractions like we did in the previous lesson. We really don't want to change, when we're dealing with graphing and linear equations, we really don't want to change our equation by clearing fractions. So if we, like I said, if we tried to do 1, we'd have 1/3 minus 3, and then we would have to turn this to 9/3, and then we'd have to subtract that. It's just extra steps. So instead of using -1 and 1, the same thing would happen if we used -1. Instead of using -1 and 1, we want to take a look at our denominator, and we want to use multiples of our denominator to multiply by. What does that mean? So that sounded a little confusing, so let's just use 3 to start with. If our denominator is 3, let's use 3. Let's see what happens. If we do 1/3 times 3, well, 3's cancel. We're left with 1. 1 minus 3 is -2. That's a whole number. If we would have used 1, we would have had like -8/3. That's not very nice. I mean, that's graphable. It's just not very nice to work with. We want to keep, for now, we just want to keep our whole numbers. Later on, we'll use fractions and stuff, but for now, let's keep whole numbers because those are easier to work with. So what did I do? I looked at our denominator. I said, let's use 3. So in the same way, instead of using -1, let's use -3. If we have a -3 up here, we cancel, 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 cancel. We still have our -1. -1 minus 3 gives us -4. Great. 2 whole numbers. And if we wanted to do it again, what other numbers could we use? We could use any multiple of 3. Let's try 6. If we have 6, we have 6 over 1. Cancel, cancel. That becomes 2. We have 2 minus 3. That gives us -1. 6, -1. And if we had -6, same thing, except now it's -2. -2 minus 3 gives us -5. -6 gives us -5. If that seemed confusing to you at all, work it out by doing the substitution on your paper. I kind of assumed that you could follow with me by multiplying, but if you couldn't, work it out on paper doing substitutions. But the rule is, if we have our fraction here and we need to do substitution, and we get to choose our variable, don't choose numbers that are multiples of our denominator, because that will give us whole numbers as a result. So we have our ordered pairs. Let's just so -6, -5, -3, -4, 0, -3, 3, -2, and 6, -1. I'm going to graph those on the next slide, and you'll see what that looks like. Okay, I'm using a little bit different of a graph this time. Notice that instead of counting by 1s, I'm counting by 2s. That's fine, as long as we're counting by 2s, and every count by 2s is the same distance apart. You'll see me use different types of graph depending on what our scale is. Like if we're counting by hundreds, I'm not going to do 1, 2, 3, 4, 5, 6, 7, 8. I'm going to do like 100, 200, 300. So just keep an eye out. Whenever you get a new graph, you want to take a look at how we're counting it. But let me graph it. Okay, take a look. We have our line again. Once again, I'm not able to trace it very well, but we have our line, and these keep going. We draw our arrows. We always want to draw our arrows when we have our line, because that indicates that it keeps going and going. And we could choose different points too. Right here is where we would have our 1, negative 8 over 3 if we wanted to graph that, but that's not very fun to use. Notice how whenever I get our odd numbers, they just go, this was a 3, negative 2, I just put it halfway between our 2 and our 4. So that's how you would graph if not all the numbers are there. But yeah, that's so we started with our equation, we got some of our ordered pairs, and then we graphed it. Let's do the same thing with this one over here. We have negative 1, 0, 1 set up, but we don't want to use those because we have a fraction again. So let's use some multiples of 3 again. Let's go ahead and use the same ones as before. Negative 3, negative 6, and 3 and 6. If we plug in a 0, 0 times all this jazz is just going to equal 0. 0 plus 4 is 4. 3 multiplied by 3. If we multiply by 3, the 3's cancel, we're left with negative 2 plus 4 gives us 2. And if we have a 6 here, the 6 and 3, the 6 will become a 2. We got 2 times negative 2 is negative 4, plus 4 is 0. Okay, negative 3. 3's cancel. We're left with negative 1 times negative 2, which is positive 2, plus 6, plus 4 gives us 6. And then negative 6. Once again, our 6 becomes a 2, and this is a negative 2 now. Negative 2 times negative 2 gives us 4, plus 4 is 8. And I will graph these on the slide. And here we have it. We have a line. I made it green to distinguish between our two lines. That line goes forever and ever. Don't forget about your arrows. So what you can notice something about these two lines. One is if we count by our x-axis left to right because that's the normal number line we're used to. But if you notice, if we go left to right, this line is going up, 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 up. It's increasing. We say that's increasing. And this one from left to right, it's going down. We call that decreasing. Just some terms will come into play later. For questions 21 through 26, we got some word problems. So let's do 22. The cost of producing X units is $2,000 plus $1 per unit. So let's write what they give us. The cost, I'm keeping it green. The cost of producing X units is, the cost of producing is $2,000, 1, 2, 3, plus $1 per unit. $1 for every unit. And our units, X units it says. So we wrote exactly what they gave us. That's all we got to write. Let's take a look at 24. The gross profit, GP, of an item equals, which means equals the selling price P minus the $2 cost of producing the item. There we go. That's all that one is. And then we got the wages W for assembling toys in a factory equals $2 times the number of toys made in. The number of toys in. That's all it is. Wages equals $2 times number of toys. All right, those were pretty easy. For questions 1 through 4, I'm just getting the indicated variable by itself. So let's do number 2. All right, x over 2 minus b equals s, and we want to get x by itself. So what's happening to x? It's being divided by 2 and subtracted by b. So we got to undo that. Remember, we're undoing, so we do PEMDAS in reverse. So even though we're dividing, we got to take care of the minus plus first. So the opposite of subtracting by b is adding by b. What we do to one side, we'll do to the other. These things cancel. We're left with x over 2. S plus b just equals s plus b. What's happening to x? Being divided by 2. To undo that, we multiply by 2. What we do to one side, we do to the other. Remember, we're doing it to the whole side. So if you need to, put parentheses around it. We're multiplying by the whole side. Okay, so remember, this kind of works as distribution now. So if you need to remember that it gets multiplied by the whole side, put parentheses so that you remember that it's multiplied / distributed through the whole side. These things cancel. We're left with x. Over here, you can just leave it like this if you want, although it's more proper to write the coefficient in front. It's technically a coefficient. Because these two things are factors. There's a few different ways you can think about it, but normally if we have something being multiplied by the parentheses, we'll put that up front. We can leave it like this. Another way of doing it is to distribute, where we can say 2s plus 2b. Either is fine. I would actually prefer this way. That way we have it broken down into factors. We got g times h times t plus k equals r. We want to get the t by itself. What's happening to t? It's being multiplied by g and h and added by k. First thing we need to do is undo that addition of k by subtracting by k. What we do to one side, we'll do to the other. These things cancel. We're left with GHT equals r minus k. You can just read that out loud to yourself if you get confused. Now, t is being multiplied by g and h. We undo multiplication by g and h by dividing by g and h. What we do to one side, we do to the other. Remember, it's the whole side. Put them in parentheses if you need to until you get into the good habit. All right, these things cancel. We're left with t equals r minus k in the numerator, g and h in the denominator. That's one way to do it. Another way is this kind of works just like how when we're multiplying by parentheses, we have to multiply by each thing, just like over here. Multiply by 2s and then 2b. We would, just like that, we would have to divide by each of them. So another way of writing this is t equals r over gh minus k over gh. It's a form of distribution. You don't really need to worry about that because normally we'll just keep it in a fractional form like this. That's what I prefer anyway, but t is by itself, so we're good. And then for 5 through 10, we got some more word problems. Number 6, the sum of the digits of a 2-digit number is 9. If the digits are reversed, the new number is 9 more than the original number. Find the original number. Holy cow! That's a confusing problem. And I gotta plug in my laptop. Okay, to be continued. Alright. The sum of the digits of a 2-digit number is 9. So, we have a 2-digit number. So, it could be something and something else, okay? So we're adding up the 2 digits. Let's just call it digit 1 and digit 2, okay? The sum of the 2 digits equals 9. So digit 1 plus digit 2 equals 9. All right, that's our first sentence. Remember, these are called subscripts. They just, whenever we have the same letter we're using for the same variable, we can use subscripts to separate them so we can keep track of them. D1 does not equal D2. They're their own independent because of the subscript. Oh my gosh, that was embarrassing, but I can't cut it out because I don't have editing services. Okay, the next thing it tells us, if the digits are reversed, the new number is 9 more than the original number. So if instead of having, so for example, this isn't the right answer, but if we had 23 and then we reversed it, we would have 32. So if we, instead of having D1, D2, we had D2, D1, it would be 9 more than the original number. So our new number, so let's go ahead and write that. Our new number is 9 more than our original number. O looks too much like a 0, so I'll do our first number. Plus 9. So that's our second sentence. Our new number is 9 more than our first number. Alright, so we got 2 sentences. I just introduced 2 new variables. Why did I do that, Bryce? That just made it more confusing with more variables, didn't it? Technically. But it's important to get your information out on the paper, because the more information we have, the more we can start to piece it together. So let's take a look at our first number. We said that our first number was our first digit and our second digit. So that equals our first number. But notice how these things aren't being added, they're not being multiplied, because how do we construct a 2-digit number? If we have 23, is it just 2 plus 3? Is it just 2 times 3? How do we get it? We get it by, well, let's think of our place values. We call this the ones place. We call this the tens place. If we had another digit, if we had a 4 here, this would be called the hundreds place. So when we write numbers, this represents how many ones we have. This represents how many groups of 10 we have. So it's not technically a 2. This is technically a 2 times a 10. and then we add 3. So if we take a look at that, 2 times 10 is 20, plus 3. 20 plus 3 is 23. Same thing with 32. That's 3 groups of 10, plus 2, 30 plus 2, 32. That's how we construct two-digit numbers. I'm dehydrated. I need water. I need food. So let's do the same thing here. Same rule. See how we took our first digit, multiplied it by 10, and added our second digit. That's what we want to do right here. So take our first digit, multiply it by 10, add our second digit. And then another way of writing that, we have a constant multiplied by I need water, by a variable. We can just treat that as the coefficient. So 10d1 plus d2 equals f. Okay. And then we want to do the same thing with our mu. Remember, we flipped the digits. Now digit 2 is first. It represents the 10s. Digit 1 represents the 1s now. This equals our new number. We do the same thing. I'll just skip a step. 10d2 plus d1 equals our new number. So I'm going to go ahead and erase everything we're not using just because it's cluttered. And I see that you can't see our 10d1 because it's being blocked by the show your work. That's ironic. Show your work is hiding work. Alright, so I rewrote all our important sentences from that. We've got 4. Now, we want to be able to work with this a little bit. What are we looking for at the end of the day? We want to find the original number. We want to find n. We want to find f. So let's go ahead and just work with our d1 and d2, since that's the first sentence we wrote. And let's use this sentence to create some substitutions. We see that n equals this, so we'll do that substitution. 10d2. And we see that f equals this, so we'll make that substitution. Let's go ahead and simplify. And notice how we have, right now as it stands, we have 2 different sentences using 2 different variables. So once we're able to substitute, we'll be able to work this problem out. So let's start by looking at this one, and we want to get all the d1s to one side of the equals and all the d2s to the other side. So let's do that first. So let's start by getting this d2 by itself. It's only being added by d1, so we'll undo the d1 by subtracting d1 minus d1. These will cancel. We're left with 10d2 equals, and then we'll subtract d1 over here. Remember, it doesn't matter whether we're subtracting over here, subtracting down here. The point is we're subtracting by the full side. So if we take a look at this now, the parentheses aren't doing much because we don't have anything to distribute. We can see that we have 10d1 minus a d1, so that'll give us 9d1, and we didn't touch anything else, so we have plus d2 plus 9. And now let's move this d2 to the other side. We can do that through subtraction, minus d2. What we do to one side, we'll do to the other. Cancel, we're left with 9d2 over here equals 9d1 plus 9. Alright, you're probably thinking, wow, this is really getting us nowhere. You would be incorrect. It just looks confusing because we're dealing with, I don't know, longer stretches of stuff. You just got to get comfortable. But as long as we're organized, it's just doing one step after the other. We really don't have to do too much thinking. It's just about setting up your sentences, and then it's just all about simplification and substitution. So now we have this. Let's go ahead and notice that. Let's notice that all of our terms have 9. Now, this isn't anything we've learned yet, but, well, it kind of. Remember when we cleared decimals? As long as we moved all the decimals the same amount, we were allowed to do that. The point is, what we do to one side, we got to do to the other. So if these all have 9, they've technically all been multiplied by 9. So as long as we divide everything by 9, we can do that. And that's technically, in this case, getting d2 by itself. We can divide by 9, and what we do to one side, we'll do to the whole other side. These things cancel. We're left with d2. And then over here, Remember, our division works just like distribution of a multiplication. We have to do it to both things. So 9d1 divided by 9, these cancel. We're left with d1. And then we got to do it to the other 9. 9 divided by 9 over here gives us 1. So look at that. That's not so bad. We got d2 equals d1 plus 1. So now, look, we got that sentence. We got this sentence. d2 equals this. Let's make a substitution. d1 plus d2 equals d1 plus 1 equals 9. d1 plus d1 equals 2d1 plus 1 equals 9. Get d1 by itself, 2d1, subtract the 1, cancel, equals 8. Get d1 by itself, divide by 2, d1 equals 4. And if d1 equals 4, let's substitute over here, d2 equals 4 plus 1, d2 equals 5. And remember, what does that mean? Remember, we originally had d1, d2. So for our first number, so d1 equals 4, d2 equals 5. That equals 45 as our first digit. Do those two things add up to 9? Yes, but remember the third stipulation was if we flip the numbers, so instead of 45 we have 54. Is 54 9 more than 45? Yes, it is. Looks complicated, right? But as long as we're organized, take our steps, write down our sentences, it's just a matter of one thing to the next. This is all something you already know. You just don't know you know it. You just have to take your time, take your steps, and it'll reveal itself to you. All right, for questions 8, 9, and 10, they have a little plus sign on them. I don't know what that means. Maybe you do. Let's do question 8. Number 8, Mr. Hayden's Bible class collected $11 in coins for a needy family. They collected wow. For a needy family, they collected $11. I'm sure Mr. Hayden could have pulled out $11 out of his pocket if he wanted. Anyway, beside the point. They collected twice as many quarters as dimes and 2 more nickels than dimes. How many of each coin did the class collect? Okay, we want to identify our subjects, or the things we don't know, the things we know. We want to identify everything. We want to write everything down. That's the key to these problems, writing everything down. So do it with me. What do we know? What are the values they already give us? They give us $11. What does that equal? That equals the total. Okay, so we'll use T for total. What else do they tell us? What are the things we don't know? What are the subjects that we don't know? What are the nouns we don't know? We don't know quarters, we don't know dimes, we don't know nickels. So those are 3 things that we'll have to deal with. Quarters, ooh, that was a dumb cue. Quarters, dimes, and nickels. So we just need to keep those in mind. Okay, so it tells us they collected twice as many quarters as dimes. So remember, we got to word this the right way. The number of quarters equals twice the number of dimes. So the number of quarters equals twice the number of dimes. Okay, that's a sentence. They also said, and 12 more nickels than dimes. Word it the right way. The number of nickels equals the number of dimes plus 12. Okay, pretty good, pretty good, pretty good. How much of each coin did the class collect? Okay, so we got our sentences that they gave us, but let's try to come up with a formula for the total up here. The total value, the total amount is equal to what? We got to use our subjects. Is it equal to the number of quarters, nickels, and dimes? No, it's not. It's equal to the total value of quarters, nickels, and dimes. So how do we get the value of a quarter? We multiply it by $0.25. Number of quarters, remember Q represents the number of quarters, not quarters, the number of quarters. It has to be a quantity. And so the total is going to be the value of the quarters, total value of the quarters, plus the total value of the dimes. Oh, I got an alarm ringing. I got an alarm ringing. What's it for? Oh, I need to get rid of that. Dimes are 10. And then we've got nickels for 5 cents. So remember, we're multiplying the value per times the total units, and that gives us the total value. Value per times total units gives us the total value, and if we add all that up, that's how we get the total value collected. Okay, so this isn't much help because we have 1 sentence and 3 variables. But luckily, we have our sentences down here. They all have a D in them. So if we make a substitution, then the only variable we're going to have left are D's. These nuts. That could be inappropriate if young children are watching, so I take that back, and I hope you can forgive me. If a young child made it 30 minutes into this video already, I guess props to you. I guess you really like math, and I guess that wouldn't have bothered you, but either way. It is a homeschooled book. I guess some homeschooled kids are watching it, so my condolences. Anyway, substitution is what we are doing. Q equals 2D, so just make that substitution. 0.25 2D. Remember, keep your parentheses. Plus D's stay the same. Plus N equals D plus 12. Remember, keep your parentheses. All right. Instead of working with a bunch of decimals, let's clear our decimals. Remember, clearing only applies to the term. It doesn't apply to each individual thing. So we need to move the decimal twice for everything. So we will do that. But it only applies per term, not per value. So we don't have to move it for everything inside the parentheses because we already did it for this grouping. So that equals 25 2D plus 10D plus 5D plus 12. Now remember, all this is still equal to the 11 as before. I just didn't rewrite it. So when we move the decimal on one side, we got to move it on the other as well. So this is going to equal $1,100 now. $1,100, where'd that come from? Don't worry, it'll work itself out when we divide everything. So let's simplify the left. We got 25 times 2D. 25 times 2 is 50 in the D. 10D. And then distribute the 5. We got 5D plus 60 equals 1,100. Combine like terms, 50D plus 10D plus 5D gives us 65D plus 60. And now, ooh, forgot a 1. And now we just got to get the number of dimes by themselves. Subtract 60. What we do to one side, we'll do to the other. Cancel. 65D equals something. I hope that's right. And then divide both sides by 65 will give us the total number of dimes, which is 16. Fun fact, 1040 is a tax form. I learned that from a new job. Alright, so if the number of dimes equals 16, then we can find the number of quarters. That's 2 times 16, which gives us 32 quarters, and the number of nickels equals 12 plus 16, 28 nickels. That tells us how much of everything we had. If we wanted to know the total value of each, we could just multiply it by their respective values, but yeah. And then question 10 to finish it off. Nicholas has nickels, dimes, and quarters. This book is obsessed with nickels, dimes, and quarters. That total 1230. So already we know what we need to do in a situation like this. 1230 equals the total, and we get the total by multiplying each value times the total number of each coin. So we can just skip right to it because we've done it so much already. Okay? And if you want, you can already move the decimal too. 2, 2, 2, 2. Let's go ahead and do that. Why not? If they're gonna keep giving us nickels, dimes, and quarters, we're just gonna anyway. It's good practice, but we've done this before and it's getting boring. The number of dimes is 3 more than twice the number of nickels. And the number of quarters is 3 times the number of nickels. How many coins of each kind do they have? All right, in this case, everything is related to nickels. Last time it was dimes, this time it's nickels. Let's do our substitutions. All right, made our substitutions. Simplify the right. We've got 25 times 3 gives us 75n. Distribute the 10, we got 30 plus 20n, and then we got a 5n. Combine like terms, 75n plus 20n gives 95n, plus another 5n gives us 100n. And don't forget about the plus 30. Subtract a 30 from each side. Oh, yeah, there it goes. We just got 1200 over here. I mean, that's not too exciting, but it's a nice round number. And then subtract the 100. Subtract 100. Just think of it as taking away the zeros. So we got n equals 12. If the number of nickels equals 12, then the number of quarters equals 36, and then the number of dimes equals 24 plus 3, 27. Bada bing, bada boom. We did it. We did it again. All right. Yeah, do your homework. You should have printed out these lesson guides and followed along with them. If you didn't, that's bad. All right. That's that. See you in the next video. Bye.